This is the Vxlan lab. This network has ospf already configured. Loopbacks are advertised. We are using Cisco CSR 1000V. Let's go to action item number 1. Given these are routers, we are going to configure bridge domains to approximate the router to the switch behavior. We're going to use the bridge domain number 200, simulating VLAN 200. So we're going to go into router 2, and we're going to configure the interface 4, and we're going to configure it to make it part of the bridge domain. So service instance 200 Ethernet encapsulation untagged. So we're going to connect here the PC with this configuration. Next, we're going to go in and create the bridge domain. This is like creating a VLAN for routers, and we're going to make it the member of this bridge domain will be gigabit 4 service instance 200. Let's do that here. No shoot. Let's create the bridge domain. Member and gigabit 4 service instance 200. Okay, let's go to action item number 2. At these routers, we're going to configure the same IP address for the default gateway, and we're going to use the same MAC address. So we're going to use Anycast for the default gateway. So interface BDI, we are not using SBIs, we're using BDIs, but it is serving the same purpose. IP address 172.116.164. The MAC address could be 1234.1234. No shutdown. Let's do that here as well. BDI 200. IP address 172.116.164. MAC address 000.124.124. No shutdown. So let's make sure that we can reach our default gateway. Okay, PC2. Okay, let's go to action item number 3. Configure multicast as the overlay control plane. So we're going to use Vxlan with multicast as the control plane. We're going to use multicast sparse mode, and we'll have to make sure that the CSR1 is the rendezvous point. So let's go to CSR1, for instance, and we're going to enable the control plane IP multicast routing distributed. Then the IP pin rendezvous address will be the loopback that belongs to CSR1, and then interface loopback 0, IP pin sparse mode, and then interface gigabit 2, which connects to CSR2, IP pin sparse mode, and then gigabit 3 that connects to CSR3, IP pin sparse mode. Let's do the same here. Conf IP multicast routing distributed IP pim rendezvous point address will be the loopback of CSR1, then loopback 0, IP pim sparse mode, and gigabit 1 that goes to CSR1, IP pim sparse mode. So let's go to CSR3, and then IP multicast routing distributed interface loopback 0, IP pim sparse mode, interface gigabit 1, which goes to CSR1, IP pim sparse mode, and then IP pim rendezvous point address will be CSR1. Okay. Let's validate. Let's do a show IP pim neighbors. Okay, these are my neighbors, and show IP pim rendezvous point. Okay, only one group so far. So let's go to action item number 4, configure Vxlan as the overlay and data plane. So we already have the control plane, and we're going to go configure the data plane. We're going to map the bridge domain 200, which is actually the VLAN 200, to the VNI 100, 200, and then we're going to have to map the VNI 100, 200 to the multicast group 269.1.1.200. So let's do that. Let's go here and go into the bridge domain 200. If you were working with switch, you will go into VLAN 200, and then we're going to make this a member for the VNI 100, 200, and that's it. We already mapped our bridge domain or our VLAN to a VNI. Next, we're going to have to create an interface, virtual network endpoint, VNE, network NVE, I'm sorry. And next, for this, the source, this is the actual Vxlan stuff. So for the tunnels, the source interface will be the loopback, and then we're going to map the VNI 100, 200 to the multicast group 239.1.1.100. And that's it. That's it. We're going to do the same here. Next, we're going to map our VLAN to our VNI. So let's go to bridge domain 200 and member VNI 100, 200, and then let's create the virtual interface NVE 1. Source interface for these tunnels will be loopback 0, and then for the VNI 100, 200, we are going to map it to the multicast group 239.1.1. Okay, that's it. We can do, for instance, show IP RP. This rendezvous point is managing this group. Let's do that here as well. Show IP pim RP. Show IP pim RP. Okay, correct. Let's go to action and item number 5. Capture traffic. Let's capture traffic here. Okay, and let's ping This I'm going to ping the other side, which has the IP address number 2. It is working. And let's see the capture. This is the ping. Notice that it is being tunneled. The source of the tunnel is, for instance, in the request, is router 2, 10.2.2.2 is sending a tunnel to the other VTEP, which is 10.3.3.3, using a UDP header that has a destination port of 4789. This is the standard for Vxlan. And notice that we have here the Vxlan header. The flags are these: GVP extension not defined, Vxlan network ID true, don't learn false, policy applied false, reserved. If you can notice, only 1, 2, 3, 4 flags are used. The other ones are not. And the Vxlan network identifier, which is 100 to 100. And this is the actual Ethernet frame. So notice we are encapsulating Ethernet inside an IP packet. So this is the Ethernet frame. It has the actual pin here. And let's go to router 1 and see our commands. For instance, if I want to see the MAC addresses, show bridge domain 200. Oh, sorry, I got this as a spine. I should go to the lead. Show bridge domain 200. I can see the MAC address that is learned from Vxlan. In this case, it is learned from the VTEP 10.3.3.3. I can also do show NVE peers. So this is the other VTEP. For instance, I can do show NVE VNI. Okay, I can see the VNI 100 200 is mapped into this multicast group. If we see the capture, we can see the ARP request. We should see an ARP request. For instance, this is the ARP request where PC1 is asking for trying to know who has the IP address 172.16.1.2. So previously it should there should be here a multicast message, because this is the response. This is the ARP request, and this is the response. This is the ARP request who has 172.16.12. Notice that it is sent through multicast. This should be the destination multicast 239.1.1.200. So multicast is used to send the ARP request, because multicast will send the message to everybody in that group. So this is why multicast is actually good to, let me hide this window capture. Okay, notice that this is the ARP request here, who has 172.16.12, and it is being sent using multicast to this destination multicast address 239.1.1.200, and it is the actual ARP request inside an Vxlan tunnel, but it is being sent through multicast, so everybody will receive this, and then the other VTEP will receive it and will answer 2.3.3.3 directly to 10.2.2.2.2. Okay, That is Vxlan. That's it.